So for today's first application, we are going to go into the marine market, which this market, our software is used quite a bit in this area, but it could be used so much more than it currently is right now. I believe the marine market could utilize this as their parts are highly organic shapes primarily, especially like the boat hulls and all those different shapes. And utilizing scan data to be able to capture those shapes that primarily are legacy designs that people understand why they work, and they have many years, even centuries of success with certain hull designs and certain marine designs, and capturing that in 3D to be able to accurately reproduce and remanufacture in the modern age. This software is, I see, highly untapped within the marine market. So this one is near and dear to my heart as far as utilizing it for this type of application. So for today's application, white light or blue light scanners were utilized in this data set. So along the lines of this one or this one or this one here, or something like this, were utilized for this type of application. So the part was put on a turntable and scanned with high resolution with these devices. These devices are very good at capturing very high accuracy, high resolution in an automated fashion. So with this application, you'll see this is a really neat part. It is a drive unit from a boat motor, and you see it has some very interesting geometry here, and you can see why somebody would want to scan it to capture it, because it is very difficult to recreate this design otherwise without scanning and bringing it into CAD. If you were going to try to model this without scan data, you can do it in a whole host of ways, but it would take 20 times 50 times longer depending on what you were doing. It is just extremely difficult. So we will go ahead and switch over to Design X and roll back through the tree and discuss how this part was modeled. So here is the part. If I go ahead and rotate it around, and you can see this is an impressive CAD model for sure. We even modeled the interior areas. As you can see here, all these interior areas as well as the external shape. So there is the CAD model. We'll go ahead and hide the CAD model and turn on the scan data. So this is the scan data. As you can see, it is beautiful scan data from a white light scanner, blue light scanner. I still call them white light because that's what they originally were. I know everybody's using blue. It's nice. It's beautiful. And you can see, look at this information. It's absolutely gorgeous. We even got some of the threads in there. You can even see the timestamp, the date stamp, and all that information that manufacturers put on there. I'm probably calling it the wrong thing, but you can see the stamped in serial numbers and the information on there. That's how good this data is. Now, it's not super dense information. This is a 1 million polygon file, but yet we still have very good resolution on here. And I'll just turn on the scan data real quick to highlight that. But you see, using intelligent decimation, we're able to reduce the overall size down to within 1 million, but yet still keep really good, accurate data here on the entire shape of the part. I just point that out. That 1 million for us, and I think I've given some of these benchmarks before on this webinar, but 1 million points or polygons actually is actually not that much for us. That's what I set my demonstration files. I set them around 1 million or less, or just a little bit less, because they present and they load up like they're nothing inside of our software. So 1 million point polygons is really not that much. in a commercial, an automotive commercial once, they showed a 3D scan I saw while watching a sporting event of a side view mirror, and they showed it in 3D, a polygon, and they talked about over 1 million measurements, and that's, they were, bragging about the quality of their measurements, which that is awesome that we are using scan data to measure parts with over 1 million data points in order to qualify a part. But it was funny to me because that's actually not even that many points for softwares like ours, and in the industry that has evolved quite a bit recently. For metrology measurement, that now is not considered that much information for scan data. So I thought that was hilarious. But let's go ahead and roll back. So I'll turn on the CAD model, and we will come all the way back to the beginning, and we will roll back. This is a pretty long history tree, so I'm going to try to skip and show the very interesting parts primarily for you, and not spend tons of time wasting everybody's time saying, yeah, here's another extrude for you. I know everybody knows how to do that by now because we've been doing this for over 12 weeks. But so I will try to show the most interesting things without boring everybody. Where this person chose to start modeling is up here. I'm sure there's a name for this right here, this fin, but this is where they started. And whatever that's called, they went ahead and did 2 mesh fits on that. So we'll just let that load real quick. So the 2 mesh fits, and we'll go ahead and make sure my surfaces are on. Come down here and turn these 2 on. So they went ahead and fit to the top and fit to the bottom. And we've talked about this over and over here, but I do just highlight that it's there if this is your first time. I can select a region on this part, and I can come over with Design X, and I can create a mesh fit. So if I come over here to Auto Surface, and then just below that stack, it's in a couple spots within our interface here. As you saw, that sometimes I go to it from a different spot, but mesh fit, I can just select that region, and you see here it's got a bounding box, so I can drag it out and say, hey, I want it to extend this much farther beyond the boundary there. And then you can select smoothness, accuracy, the number of control points. Do I want to fit based on deviation or based on resolution of the surface, the NURB surface? And we even have some extended ones where we can show how it extends, linear, the extended ratio, all kinds of cool stuff there. Now, if I hit next, you'll see it does a preview, and I have the ability to adjust that, and then I can hit OK. And you'll see that it creates another mesh fit over top of it. So you see how quickly it is to create those mesh fits. Now this person chose to do it with a mesh fit, but you could also use that loft wizard if it's something that you see that you want to edit later and make specific changes to it. You can use the loft wizard in order to then use the cross sections and make tweaks and changes to it. So you could, those tools are really interchangeable, the loft wizard versus the mesh fit, depending on what you're trying to do with it. So we'll go ahead, and this person then created a sketch and extruded it. So we'll just turn off the regions, turn off the mesh, and you'll see there that they went ahead and just extruded that boundary of that surface. And so I'll just come in here real quick, and they did a silhouette. So again, I highlight this often, and I know I beat this over and over again, but the silhouette feature inside of Design X is just amazing. So I can come in here, and you see here that they silhouetted the entire outside of that shape, and then they drew and sketched directly over top of it. And it is just so much faster to be able to come in here and snap things. And you can even do it with you see here with splines where I can just window in and tell it to fit a spline, and I can adjust it smooth, very smooth, adjust how many points it's using, all of that. So that was just a spline, but you can do that with all of the different features here. So I can say I want to fit a line to this, and then I want to do a tangent arc from here, and I can, what's so nice is you can visualize the radii and then make determinations like, oh, that is a radii, that is a radii, and you can make, again, determinations as to what is one constant radius versus, and I didn't estimate those exactly well, but you can make the determination of what is a constant radius versus jumping over to splines and doing it that way. So I'm going to discard the changes, and you see this is the way they made it, one constant radius with a few different segments there, and that is how they created that sketch. So now that I'm out of here, you see there is my shape, and then they're going to do a top and bottom cut. Boom. So we went ahead and we created that piece, and then they're going to do a couple cleanup things where they're going to do chamfer and fillets to it while they're at it. So they're doing a chamfer here to kind of take that and taper it down. So instead of doing a cut from the side, I tend to like default always to using the same tools that can do the same job, but they actually used a chamfer there to chamfer that down on this end piece. You see that it dips and the thickness isn't constant. So now they're going to go ahead and create a sweep along the rear end here. So we'll just zoom out. You see there, if we zoom out, they went ahead and created a sweep along the back, and they utilized these two sketches. So one profile sketch that they used here, one profile sketch there, and then another profile sketch to guide it throughout that data. And then, of course, use that to then cut away and then apply some fillets to the top and bottom. So we'll go ahead and just go forward through all of those. So now we'll go ahead and turn the surface off. We've got that portion, and let's see where they go next. So it looks like they're going to create a sketch and loft and extend. So let's just go ahead and zoom out. And we'll turn these surfaces back on. All right, so now we're really digging into the main thing. When you look at this, the shape of this part, I would imagine anybody that likes to 3D model, they are looking at this, basically dissecting how they would go about modeling the part. So you see, they started out saying, okay, this middle area from here forward is a constant extrude vertical. So they fit a constant extrude surface, this guy, straight down. Then around here somewhere, you see here that it changes and it's a nice organic shape going up and down here. So they went ahead and did a loft, and we'll just hide this, where this dives down and follows an angle here. Now these are just the roughed in, as many of you have noticed so far. The way we go about modeling in here sometimes is we go ahead and fit a bunch of surfaces, then trim them back and loft them together and stitch them, and that's going to be that same sort of workflow here, where we go ahead and rough in the pieces that we're going to like drape. Think about upholstering it with CAD surfaces, right? We're going to drape a surface over it, and then we're going to cut the shape of the outside of it, and then we're going to stitch it together with the surrounding areas. I mean, I know I use that analogy often where upholstery, but CAD surfacing is very similar to upholstery in a lot of different ways. So now we're going to go ahead and you see here they did a 3D sketch to do a surface trim trim both of those surfaces back and then loft between those surfaces. So you see we went ahead and connected those together and we show it with it here that we got it going here. And if I go ahead and turn on deviation, you can even check your deviation. You see that one area is because there is a vent there, or what I'm sure there's a term for this in the marine world, but yeah, there's a piece there that's we haven't modeled yet. And of course, then we sew that together, and then now they're going to go ahead and do the same thing where we loft another surface and then trim it. So I'll skip forward. I'll skip forward to about there, and we'll talk about that. So now, if I turn this off, we went ahead and fit a giant lofted surface this direction. If you turn the scan data back on and off, you can see where we went with that. And then what we're going to do is trim it back. Like so. And then fillet the in-between area. You'll see that actually it looks like they're going to leave that for a second and fit some other areas first. So let's just take a gander here what they're going to do. Okay, so we went ahead and we fit a surface over here. It looks like that's the cylindrical surface on this left-hand side. And then we're going to trim and sew this all together as one piece. So we made a tool that's all together. And then now we're going to go through loft, loft, sew, loft, loft, sew, all the way down to make all of this connect together in a nice orderly fashion. So some people might ask, why don't you just select here and there and make it all fit together in one shot? What ends up happening sometimes when you have different ordered paired sides is that there's like some wrinkling of the NURB surface if you don't map this to that, and make it very specific. Here, I accidentally did not hit move forward here. So you see here, what we're able to do is go ahead and map these so it's a nice order. If you try to do that all in one from edge to edge, a lot of times you'll have it like stretch and streak, and it's like taking a piece of fabric and pulling it and making it stretch in an awkward way. That's the same thing with these NURB surfaces because they want to be four-sided patches. Yes, you can trim them in different fashions and make them a trimmed surface, but underlying it's still using four-sided NURBS patches with trimmed edges. So that is why you can cause wrinkles, and there are general modeling what do you call it, best practices in order to create nice clean NURB surfaces for CAD modeling. So there are some best practices that you learn in any software, whether it's SolidWorks, CATIA, NX, any of those. If you get into the advanced surface modeling, that there are these skills that you learn that are basically how to create nice clean surfaces so you're not creating wrinkly stuff here. All right, so what we've done here is they went ahead and mirrored this across. So that absolutely beautiful so far. This is really cool looking. And if we go ahead and turn the scan data on, this is what we got so far. So it looks like the next stage of the project is to go ahead and maybe create the bottom piece, I think is what they do next. So we'll just roll forward a few. So you see that they went ahead and fit one, they just went ahead and put one mesh fit all the way across this area here. And since we have just absolutely gorgeous scan data, it fits extremely well. And then we'll go ahead and mirror that and stitch it and trim it. So they went ahead and mirrored it across. And stitch and trim together. So let's go ahead and turn the solids on. Turn the CAD off. So actually what they did is they did a cut. So they did an extrusion with the outer boundary of this shape. If you turn the scan data off. And then they mirrored that and cut both sides with the surface. So that is what we did here to create that shape. Absolutely looks good. Then we can go ahead and add some of our fillets to it and dress it up nice. But you'll notice here that there is a nice giant blend on both sides here. I think it's on both sides. We'll see here in a second. So we went ahead and added fillets to that in the different corners. And now let's see where we go here. Yeah, so there is a more constant radius blend down here at the bottom, but up here, a very specialized blend of this rotational, this revolve, and these organic surfaces here. So let's go ahead and see how they accomplish that. So we'll go ahead and fast forward through all these fillets. Turn the scan data off. So you see we put more fillets and dress up features here on the bottom side. Now we're going to get ready for the real magic here. Some mesh fits and trims. So we're going to go ahead and mesh fit some surfaces here. So turn that on and off and make sure the surfaces are on. So we'll go ahead and hide some of the ones we're not using right now. So we fit these three. And again, think about it. This my upholstery example. It's like drape, drape, drape. At first, you look at it and you're like, "What are they doing here? It's not looking good to me." But as you go through and dissect, after you lay those surface patches and then you trim them back, you'll see how we stitch it all together and it comes together looking beautiful. So there's the first one, loft it, second one, loft, and sew. So I'll fast forward through all of those. So that's starting to look a lot better there, where we got that nice surface draped over top. Now, they had a really creative way of going about this. So they look at that top surface that we just created, and they went and they took a 3D sketch and they just trimmed it back with that nice flowing shape that the polygon has. So if I come in here with the polygon and I turn off the CAD surface in solid, you see here that there's this nice beautiful swoopy shape that then we captured with that. And then the same thing goes for this side too. So we're going to follow this shape. We're going to split the solid CAD face and then delete the face. And we're going to do that here and there. You'll see they're still working on this side right now. So if I turn off the polygon. So we turned off the polygon there. And you see here we broke our solid because we trimmed both sides of the CAD and deleted that surface because we're going to trim and stitch this in here. Now we're going to do what we just talked about, where we loft, 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 stitch, 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 all back together. to go ahead and connect this piece in with the main body. So you see that they put all those, and then we will do the same thing. We'll do split face, delete. So I'll go fast forward there, and we created that. Now, what they decided not to do is do those yet. Just go ahead and get this trimmed in with everything first. And now we're going to go ahead and loft, sew it all together, and then mirror it to the other side. So you see we went ahead and stitch it together. We still have more to do to fill those. If it was me, I probably would have filled these first. That way, when you mirror it, it all goes across and you don't have to do as much. But that is just me. So that there is the shell. So we'll go ahead and you'll see here loft and sew. And then we should have that part buttoned up here for the most part. We'll just check and see if there's anything missing here once it finishes. If they left something out over there. But you see, that was just a really neat way of creating that surface by fitting these surfaces and trimming them together. Yeah, so there's a little bit more dress up work down here where we loft, sew, fill face. I'll just skip forward because there's just a lot of that. There we go. So once we've filled all those surfaces and buttoned everything up, you'll see that now we end up with a solid. Beautiful. And then turn on the scan. So you see there's our. So now let's see where they go next. So it looks like they do an extrude and a sweep and a cut. So let's just kind of zoom forward. Okay, so now they're going to start working on the top. So they're doing an extrude, and then looks like there was a sweep on the end, and then did a cut on the end over here. Perfect. And now it looks like they're going to move up here and build out this flange and hollow it out. So a lot of this stuff is chunking out with extrudes and fillets and revolves and stuff. So I will skip forward a little faster on this area because it's like, okay, we build a tool, chunk it out, cut it, merge it in. So you see what we're doing here. So you see there, went ahead and created that flange. And then they're going to go through and create all of these side cutouts here too. So I'll just skip forward on some of these because it is a lot. We'll see if there's anything in here that's interesting, that's not just basic cutouts and stuff like that. All right, so yeah, we just cut these out and then filleted the shapes, cut it out, fillet the shapes. And we'll just keep zooming forward here. So you see there, we hollowed out this area and knocked some holes out there. So more just regular stuff, just a regular model in there. We'll just jump forward. Now we jump forward to this part, which is very interesting. Turn on the mesh. Turn on the surface there. So it looks like we're going to model this cutout. So I jumped forward a few different steps here. They went ahead and did a surface extrude there. They created a vertical surface here and then trimmed it all together. So if I hide it, you see that fit, trim, all this together. and keep going forward. Let's just keep going forward and see what they do here. Okay, went ahead and trim it all together. So they deleted a face, created a surface, and then did this surface trim all together here. Just zoom out here. And then they're going to go ahead and loft and sew it all together. So let's go forward a few. And it looks like now it's going to be a solid. So I'll go ahead and turn my solids back on. So we're back to a solid here. Now, there's different ways of going about this, like depending on how you want to do stuff. It could be the reason why they did it that way is because the way all of this was going to blend together and make it coincident and make it all blend in would be easier to use these lofted surfaces to stitch this in. Because if I made a tool and chunked it out, sometimes you're going to end up with a slight ledge or something. And there's a ways around it. Like you could do like a split face, convert entities, blah, 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 and do all this stuff. But the way they chose to do it is they went ahead and cut it away from the surface, deleted faces, and then did blends over here, which is a good way to do it as well, I think. So now let's jump forward a bunch of steps and see where they go from here. Okay, so it looks like they leave that alone now. And they jump up over here and start modeling here and cutting all this away. So they did a revolve cut and created some holes in here. So again, we'll move forward faster through some of this stuff. They're creating this and they're really worried about just one side here, and then they're going to do more mirroring here in the future, just to let you know. So there we go. Went ahead and knocked out a bunch of that. Roll forward here, more cutouts, more modeling in that area. We'll just keep going forward here. I think the next thing they go up top. All right, up here they start cutting away. And again, they're just worried about one side at the moment because we're just going to mirror again for a lot of this. So what they did is they went ahead and did some cutouts and fillets over here, cutting all that away. And again, I'm going to fast forward because we're near the end of this one. And a lot of it is self-explanatory based on stuff that we've already discussed. So just a lot of features describing the shape of this part. So then they cut all this away using surfaces and cuts and booleans, and a lot of it is you create a tool, and if there's something on a different axis, then you would cut away from that tool and then boolean that shape away from the overall body here. So now we went ahead and cut away from this side. You see here we're getting ready to do the big mirror. Scroll forward here. So you see what we got. Half the part, that interior shape all cut away. Surface modeling, a tool to cut away from the interior shape here. And now we are going to mirror and add some dress up shapes. So we'll just go ahead and roll to the end here. So there she is in all of her glory here. They added some shapes here too. Just a really neat, we'll just turn the surface off there. Just a really neat shape overall. So that is the drive unit, the lower drive unit. Really cool application there.